Hey guys, welcome back. Let's move on to another lab from HTTP Request Smuggling, where we are gonna see exploiting HTTP Request Smuggling to perform a web cache poisoning. I already recorded the whole module of web cache poisoning vulnerability. You can go to the playlist and check that out for in-depth knowledge. So here in the description, it's saying this lab involves a front-end and back-end server, and the front-end server does not support chunked encoding. That means the front-end server will interpret the content length. The front-end server is configured to cache certain responses. Okay, that we need to see because this is where the web cache poisoning exists. Okay, so we will see that in a minute. To solve the lab, perform a request smuggling attack that causes the cache to be poisoned such that a subsequent request for a JavaScript file receives a redirection to the exploit server. The poisoned cache should alert document.cookie. Okay, so we will have exploit server here in this lab that we will see. Now this is, let's start the lab. Okay, so this is our lab. I'm gonna make this a little bit smaller so that you can see both of these windows simultaneously. And here you can see this is our web root request. I'm gonna send this request 2 times, one for the attack request and one for the normal request. And as we saw before, because this lab is more about exploiting the web cache poisoning by exploiting HTTP request smuggling, and here in the lab description they already said that the front-end server is configured to cache certain responses. So we need to analyze these responses what we got while we access the lab. So if we go to another request, which is /resource.js is tracking.js, so here you can see in the response you will find here response header, that is cache control, where the maximum age is 30 seconds, and you can see because this was the first request, so the age was 0, and X cache is missing. So if the response basically come from the cache, so here you will find the hit, otherwise you will see miss. So this is the request, this static resource. If you access this static resource, basically it's using, the front-end server is using the cache for this particular static resource. Fine. So in the response we find this, although if you see the web root request, there you will not find any cache control or maximum age or X cache hit or miss. If you go to this, you can see this is also the static resource, and here you can also see the front-end server is using cache. So it's basically caching the responses, and another user come to get that same resource, it will provide the response from the cache. Fine, until 30 seconds. So all the static resource, that means used cache. Fine. So this is also important. So anything you can take it from here, any request that is using the cache, because this is what we are going to exploit, or we are going to use it, okay, to exploit HTTP request smuggling. I'm gonna send this request also. Okay, now go back to our repeater, and this is our first request. The first thing first, I'm gonna change the request attribute from HTTP version 2 to 1. For this request also, I'm gonna change it to HTTP version 1. Second thing, I'm gonna turn off the update content length, and here I'm gonna right click and change the request method. Next thing, I'm gonna delete all these headers which we don't need, and we are gonna add transfer encoding here. So transfer encoding header, and the value is gonna be chunked. Okay, so first of all we need to make sure whether the server is vulnerable for, or the application is vulnerable for TLCE or CE.TL. So for that purpose, let's see, I'm gonna first check whether the front-end server is using transfer encoding or not, and for that purpose I'm gonna put here the chunk size 4, and the value of, or the data of that chunk is, let's say 4 times A, and then I'm gonna put here an invalid chunk size, which is M, because the chunk size represented in the hexadecimal and M is invalid hexadecimal character. Fine. So let's see, if you want to enable the turn line feeds, you can enable it by clicking this one, and I'm gonna send the request. So okay, I'm gonna cancel it because I need to also mention here the content length. So for content length, we need to just highlight from the last A up to the 4, and you can see there are 7 bytes. So I'm gonna convert that 0 and update the content length from 0 to 7, and let's send the request. So once we send the request, if the front-end server is interpreting transfer encoding, which is not, because even in the lab description it's saying that the front-end server will not interpret or support the transfer encoding, so it will see the complete thing as data, not as the chunk size. So here you can see communication timeout, because the front-end server is not interpreting it as a chunk. Fine. Otherwise, if the front-end server uses or support transfer encoding, you will see here invalid request, because the front-end server that time will see the first chunk size, chunk data, then come to the second chunk size, which is invalid. So here you will see invalid chunk size or invalid request. But the front-end server is using content length. That's why we are seeing here communication timeout. So that tell us that the front-end server is using content length. Now, once that is confirmed, I'm gonna make some changes in our attack request. So I'm gonna put here 0, because the backend server will use the transfer encoding, and 0 means the message ends here, and the second request will start from here. So I'm gonna say get slash anything. This is absolutely same what we did in the very beginning of this HTTP request smuggling vulnerability module. So I don't think you will face any issue up to this part. Okay. Now here I also want to put content type and content length. So I'm gonna copy it and paste it here. Come on. Control C, Control V. Okay. And then I'm gonna put here some data. Let's say I'm gonna say fake is equal to data. Okay. Now we need to update this content length. It's always better to go from the bottom. So I'm gonna highlight the content. You can see there are 9 bytes, but I want to increase a few more bytes. Okay. So I make it 12. And for this one, because I want all of this data go up to the backend with this request as the post body data. So I will update the content length by this approach, or you can just turn on the update content length. Okay. So send the request 200. Okay. Now go to the normal request and send the request, and you can see not found. Why not found? Because this endpoint does not exist, and that's why once the application try to access it, it's saying not found. So that is absolutely fantastic. We are on the right path, and this confirms the CL.TE vulnerability. Now back to the main point, where I need to basically, according to the lab, we need to poison the cache in such a way that we get or popped up alert for the victim users with the document.cookie. And for that purpose, we need to use the exploit server. So exploit server, we will consider this exploit server as an out of band interaction. And for that purpose, we need to also find out a way from where we can basically access the exploit server. Because if we just come back here and we try to go to anywhere, let's say this is the normal request, and if we try here, let's say example.com and send the request, it's saying forbidden. So from this way, basically the front-end server is validating the host header to find out whether the host is allowed or not. Okay, so that's not gonna work. Let's go back to the application and open a post. And if you scroll down all the way to the bottom, and you can see here there is another link for the next post. And if you click on the next post, go back to the burp suite proxy, and this is the request for the next post. Okay, so here basically I'm doing all of these by identifying everything in the beginning. I know from where we need to get the things, but in real life you need to find out by checking all the requests or maybe other features in the application. Fine, so keep that in mind. I'm gonna send this request to the repeater, go back to the repeater. Now the same thing I'm gonna repeat here. If we just send the request, you can see 302 found. That means it's redirecting us to this location. And you can see this post number, post ID is 5 and this post ID is 6. That means we are going to the next post or jumping or hopping to the next post. But what I need here is to find out whether I can go somewhere else. So example.com and send the request one more time. Now you can see here it's still saying invalid host. Fine. So what we will try here in that way means there is no way you can go for the out of band interaction by this approach. So we will basically try that purpose with the request smuggling, HTTP request smuggling. So here what I'm going to try is, let's see, this is the next post request. I'm going to copy this back here, and instead of anything I'm going to paste it here. Fine. So let's go. I'm going to send this request and go to the normal request, just send the request. 200 okay. That means it's not working, so we need to check it multiple times. Send this request another time and send this request another time. We should see 302 found. Yeah, 302 found. So you see here, once we try to send the normal request for the next post, the response is 302 found and it's redirecting us to the next post. And same thing we did here. We put this URI, we send it, we go to the normal request and we try and we see the response as 302 found. So that means the attack request is working fine. Now we need to test whether we can go for the out of band interaction or not. So I'm gonna add here host header and I'm gonna see, sorry, example.com. Okay, now send the request one more time. 200 okay, send the normal request. 200, 302 found, and you can see now this time it's trying to redirect us to the external domain example.com. Okay, so this is what we need. If we can interact to any other server out of band for the out of band interaction, at that instant we can use our exploit server to basically serve any vulnerable or any malware script, and we will do that by the exploit server. So I already go back to the exploit server. So I already open up the exploit server. This is our exploit server. Now here I need to change the endpoint, because what we are using here is /post, right? /post. Okay, and another thing, the content type we will use text /JavaScript, and here we need to say alert document.cookie. Okay, fine. Yeah, we need to pop up an alert document.cookie. So this is what we save here. And one more thing, we need to terminate it with the semicolon and store it. Fine. Now the thing here is why we need this. web cache, because if we send the request, you will see there is a cache. So once a response is cached by the front-end server, next time whenever any user try to access the same resource, the response will be delivered by the cache. So the front-end server every time will not go to the back-end server to ask the response. It will just cache it or store it for a limited amount of time, and whenever any user from outside try to access the same resource, it will provide that response from the cache itself. So what we are basically trying to do here is, let's say, go to the attack request, and I'm going to copy our exploit server host name, which is this, back to our attack request, and instead of example.com, I'm going to paste the exploit server host. Okay, so what we are basically trying here, so once we send this request, okay, because every time once the user try to access the home page, okay, or once the home page is delivered, this static resource is also delivered with the request, with the response. Okay, so whenever I try to go to home page, you can see all these static resources also delivered or loaded with that response. So our front-end server will basically cache the response, and another time once the user try to, or victim user try to access the application home page or anywhere, and this page is loaded or this resource is loaded, it will get our script, okay, and pop up the alert. So this is what our purpose is. So I'm going back to the static resource, which is this one, send the request. So this time, because this is the very first request, so the age is 0 and X cache is miss. Fine, go back to the attack request and let's just send the request. So you can see 200, okay. Now go back to the static resource, send the request. Okay, we should see here 302 found once the response comes from the cache. So let's just see 25 seconds, send the request one more time. 302 found, okay, and let's try to refresh the page, nothing come. Back to our request, which is this one for resource tracking. Send the request, 13 seconds, you can see 15 seconds, 17. I'm gonna wait up to 25 seconds, and after 25 seconds we will send the request. Okay, 25 seconds now. I'm gonna send this request, which is our attack request. Go back to the tracking.js request, send it. You can see 302 found, and it's redirecting us to the exploit server, back to the application, and try to refresh it or load the home page. Now the alert must be popped up, and you can see document.cookie alert is popped up, and in this way we solve the lab. So that's it for this video. I hope you enjoyed. If you like the content, please like, subscribe and share. I'm going to see you in the next video. Bye.